All right, so get ready because we are diving deep into some serious code thinking today.
Yeah, influential stuff,
Courtesy of SICP,
which is,
Structure and Interpretation of Computer Programs.
for those who haven't had the pleasure.
Right, exactly. And you sent over some excerpts, and it looks to me like it's from the second edition.
Excellent eye. You know, it's interesting because SICP, it isn't like, your typical learn to code type of book.
Right.
It's really a deep, deep dive into the essence of programming.
Yeah, it's almost like a philosophy of code in a way.
Yeah, I like that, philosophy of code.
So we're spelunking into these excerpts, not to get bogged down in all the details of the code or anything, but to really unearth those nuggets of insight,
Right.
those aha moments that make SICP so legendary.
I think even for those who are seasoned programmers, it's always a great book to revisit because it really is about, seeing code through a different lens.
Right, yeah, absolutely. And so right off the bat, in Chapter 1, SICP hits us with this idea, and that's building abstractions with procedures.
Okay.
Now, I know that those words might sound a little bit intimidating,
Yeah.
but just bear with us because it gets really interesting.
Yeah.
So what exactly do we mean by abstractions and procedures in this context?
So you can think of abstraction as this idea of managing complexity.
Hmm.
So you know how, for example, you know how to drive a car, but you don't necessarily need to know every single detail of how the engine works.
Right, yeah. The magic happens under the hood, and we just see the result.
Exactly. So you're abstracting away all of that complexity. You have the interface, which is the steering wheel, the pedals, and all that, and that hides all of that complexity from you. And in the same way, with programming, we create these higher-level tools, these procedures, which basically encapsulate a sequence of actions. They take some input, they perform some operations, and then they give you back some results.
So they're like pre-built modules or libraries that we use in our code
Exactly.
to simplify things and let us work at a higher level.
And the beauty of that, too, is that when we're writing code, yes, the computer has to understand it, but really it should be written for humans to read.
Which is great news for those of us who have had to decipher code that looks like it was written by some alien civilization.
Right. And that's, I think, the brilliance of this idea of abstraction.
Yeah.
By creating these well-defined procedures, we make our code so much more readable and understandable, not just for ourselves, but for others as well.
Right. It's like, if you were to get some furniture that you had to put together, you would want to have a set of instructions, right? You wouldn't want to just have a jumble of parts and try to figure it out.
Exactly.
And so in the same way, well-written code is like a set of instructions.
Right.
That's easy to follow and understand.
Well said.
And speaking of elegance in code, SICP throws another kind of mind-bending concept at us, and that's recursion.
Yes.
So what is recursion, and how does it fit into this whole picture?
So recursion is this idea that a procedure can actually call itself within its own definition.
Okay, so when you say that, I'm imagining my computer going into some kind of infinite loop and smoking.
Right. Yeah, it can be a little dangerous if you don't set it up right.
Right.
But the way I like to think about it is like those Russian nesting dolls.
Okay.
Where you open one up, and then there's a smaller version of the same doll inside. And the reason why recursion is so powerful is because it allows us to break down these complex problems into smaller, self-similar subproblems.
So can you give me an example of how recursion would actually work in practice?
Yeah, so imagine you want to calculate the factorial of a number, let's say 4.
Okay.
So the factorial of 4 is just 1, 2, 3, 4, right?
Got it.
But with recursion, you could define a procedure that says, to get the factorial of 4, multiply 4 by the factorial of 3.
Okay, but now we're back to we still need to figure out the factorial of 3.
Exactly. And so to calculate the factorial of 3, you apply the same rule. You multiply 3 by the factorial of 2 and so on. And there's a base case, like a starting point. So the factorial of 1 is just 1.
Ah, okay. So it's like this chain reaction that eventually stops once we hit that base case.
Yes. And then it kind of unwinds and gives you the final result. But what I think is so cool about recursion is that this pattern, it's not just in computer science. You see it in mathematics, you see it in art, you see it in nature. It's this really elegant way of solving problems.
Wow, that's a really powerful concept. So we've got these building blocks of procedures and this really mind-bending idea of recursion. What else does SICP kind of throw our way in these excerpts?
So it seems like the next thing it really dives into is this idea of time and efficiency in computation. So, how quickly can we get our programs to run?
Right, because it's not just about getting the job done, it's about getting it done well and efficiently, right?
Exactly, exactly. And it looks like SICP introduces concepts like linear versus tree recursion and how these subtle variations can really impact the performance of your program.
So it's like choosing the right tool for the right job.
Exactly, exactly. But I'm curious, when you were looking at these excerpts, did you notice if SICP went beyond just numerical data?
That's a great question because it feels very number heavy right now. Does it go beyond numbers?
Yeah, it does, because, in the real world, we're dealing with a lot more than just numbers.
Right.
We have text, we have images, we have all sorts of complex data structures.
Yeah, and SICP actually talks about this, doesn't it? It's this concept of, what was it, compound data?
Yes. And I think that's actually another area where SICP shines, because it doesn't just deal with, like you said, just numbers. It tackles this idea of building these more complex data structures.
Right, so instead of just dealing with individual pieces of data, like a number or a letter, we're talking about combining those elements to represent more complex information.
Right, and it's like, how can we take these simple building blocks of data and combine them in a way that allows us to represent these more sophisticated ideas?
So it's like, with those Lego blocks, if we think about each individual Lego block as a single unit of data, how can we put those blocks together to build a house or a car, something that's much more complex and intricate?
Yes. And that's actually where this idea of data abstraction comes in, right? So just like with procedures where we were abstracting away complexity, data abstraction is this idea of hiding the complexity of how data is represented, so we can work with it at a higher level.
So with data abstraction, we're not just wrangling individual bits and bytes. We're dealing with these meaningful chunks of information.
Right, and it allows us to create more complex systems.
Yeah.
And, this actually leads to one of the more, I think, interesting aspects of SICP, which is this idea of symbolic manipulation.
Okay.
Because now we're going beyond just crunching numbers, and we're actually starting to manipulate symbols that can represent these more complex data structures.
So like, are we teaching the computer algebra instead of arithmetic now?
Yeah, in essence, yes. And so SICP uses this example of symbolic differentiation, where you write code that doesn't just calculate the derivative of a function at a specific point, but it actually derives the general formula for any point.
Okay, that's some next level math stuff right there.
Yeah.
How does SICP even begin to approach something this complex?
Well, it uses that power of abstraction that we talked about. So breaking down this really complicated task into smaller steps. And of course, recursion comes into play as well, where these steps can then call themselves. It's like those intricate machines where each gear and lever has its own specific function, and together they create something much greater.
Yeah, I still have nightmares about trying to get through calculus in school, and this just blows my mind. The fact that we can connect these fundamental programming concepts to such complex mathematical ideas is amazing.
And this is where I think the language of SICP really shines through, because it's Lisp, right?
Sure.
And Lisp has this really unique ability to treat code as data.
Mm.
And so it becomes incredibly powerful for symbolic manipulation.
So it's like Lisp was almost tailor-made for this kind of abstract thinking?
Exactly, exactly. And then as we move on, it looks like these excerpts you sent also touch on this idea of streams.
Right, streams, which are pretty cool. Yeah, they always kind of seem like magic to me. It's like this data that just keeps flowing, this infinite river of information.
That's a really good analogy. It's like when you're, streaming a video online, you don't have to download the entire movie before you can start watching.
Right.
You're getting this continuous stream of data, and then it's being processed, kind of in real time.
Yeah, so instead of dealing with all of the data at once, we're processing it piece by piece as it arrives, which seems like it would be incredibly efficient.
Exactly, exactly.
Mm-hmm.
So you can work with these potentially infinite sequences of data without, your computer crashing. It's kind of like if you were to imagine like reading a book, an endless book, but you only read one chapter at a time.
Right, exactly. Yeah, I love that analogy. And it really does seem like this idea of breaking things down into these smaller, more manageable chunks is a recurring theme here in SICP. And, it also reminds me of those two other terms that popped up, and that was modularity and objects.
Oh, yes, yes.
So how do those fit into this whole conversation?
So modularity is this idea that, we want to organize our code into these smaller self-contained units. So we can think of these as like modules. And so the idea is that each of these modules, it has a specific purpose.
So instead of having this one massive tangled web of code, we have these neat, reusable modules.
Exactly. And it makes your code so much easier to understand and to maintain as well, right?
Right, absolutely. And so then objects, they're kind of like modules, but on like a super powered level.
In a way, I mean, objects, they take this idea of modularity one step further.
Okay.
Because now, instead of just having code that's organized into these modules, an object actually bundles together both the data and the procedures that operate on that data.
So it's like having a blueprint for, say, a house. It's not just the design and the dimensions, but it also might include instructions on how to build it.
A perfect analogy.
Or even modify it, like, how to add on an extra room, change the layout, whatever we need.
Exactly. And so this idea of encapsulating both data and the operations that you can perform on that data, that's what makes objects so powerful, especially for building these complex systems.
And it makes sense that this idea of objects kind of naturally leads to the object-oriented programming paradigm that's so prevalent today.
Right, exactly, exactly. And you know what's cool is that even though SICP doesn't explicitly talk about object-oriented programming as, like, this paradigm, it plants the seeds for those ideas.
It's like it lays the groundwork for so much of what we take for granted in modern programming. It really shows you how influential and timeless a lot of these SICP teachings are. And speaking of timeless, I love how SICP throws this really kind of like mind-bending concept where it says that any program, even an evaluator, is itself just a program.
Oh, yes, yes.
What do they even mean by that?
It's so meta, right?
What do they mean by meta, though?
Well, think about it. An evaluator, it's this program that's determining the meaning of other programs.
Right, right.
But SICP is saying that even the evaluator, it's just another program. It's subject to the same rules and principles as any other program.
So it's like this evaluator is looking in a mirror and it's seeing itself as just another program.
Right, yeah. And it gets even trippier, because like in Lisp, where code can be treated as data, now we're not just evaluating code.
Right.
We could potentially be writing code that writes other code.
Whoa.
It's like the program can modify its own blueprints.
It's like that concept of metaprogramming I've heard about in other languages like Python.
Yeah, exactly, exactly. SICP may not explicitly use that term, but the idea is definitely there.
It's like it's pushing us to think beyond just, giving instructions to a machine. It's like we're creating these new systems of expression and thought.
Exactly, and I think that's what makes SICP so relevant even today, because it's not about, a specific programming language or a specific framework.
Right.
It's about understanding these fundamental principles of computation.
Right. Like it's about giving us the mental tools to not only just like navigate the world of software, but to actually shape it.
Exactly. Couldn't have said it better myself.
Yeah.
So I'm curious, as you were going through these excerpts, was there like a particular aha moment that stood out to you?
It's funny because I've always been kind of like intrigued by recursion. But when you were describing it in the context of SICP, and especially like that Russian doll analogy, something just clicked for me.
Right.
It finally made sense. This idea of breaking down these complex problems into these smaller, self-similar pieces, it's such an elegant approach. How about you? What really stood out to you?
Honestly, I think for me, it's always been the emphasis that SICP places on abstraction.
Yeah.
Because it's such a, it seems like such a simple concept.
Right.
But has these really profound implications for how we design and write software. It's this constant reminder that complexity can be managed and elegance, it is achievable through that careful thought and extraction.
Absolutely, yeah. And for anyone listening, if any of this has even remotely piqued your interest, I highly recommend checking out SICP.
Yeah?
It's a challenging read, but it's a rewarding one for sure.
It is. It's like climbing a mountain, right?
Yes.
It's tough.
It's a journey.
But then the view from the top is incredible.
Yes, beautifully said. And before we let you go, we want to leave you with one final thought-provoking question to ponder.
Okay.
So we talked about how SICP, it kind of challenges us to think about programs as data, and that there could be programs that can evaluate themselves, right? Or even modify themselves.
Right. Yeah.
And that's already mind-blowing, but think about this. If a program can actually modify its own code, what does that mean for its potential to learn and evolve?
Oh, wow.
Could we create systems that don't just follow our instructions, but can adapt and improve and even surprise us with their own ingenuity?
It's a great question.
It's a question that goes way beyond just the lines of code that we write, right?
Right.
It touches on the very essence of, like, intelligence and creativity.
Exactly.
So that's something to chew on. But for now, thank you so much for joining us on this deep dive into the mind-blowing world of SICP.
Thanks for having me.
Until next time, keep coding, keep questioning, and keep pushing the boundaries of what's possible.